gravity and how it can shape Earth through erosion and deposition. This is on the fourth and last page of your second packet of notes. So you're going to use this slide here, to help you answer this question in your notes. So gravity influences the movement of water and ice. So gravity is one of the driving forces on pushing glaciers down slopes. It's the driving force that causes water to flow downhill, influencing a stream or a river. Gravity can also cause rocks and soil to move downslope. The shifting of material, rocks and soil, is called mass movement and plays an important role in shaping Earth's surface. So take a moment and I would copy these 3 bullet points down into your notes and how can gravity shape the Earth. So we're going to look at several landforms or events that happen because of gravity. So you're going to write a description of that landform or event, attempt to draw a picture or image for it, and then note whether it is erosion or deposition. The first one that we're going to discuss is called creep. Most slopes are undergoing mass movement even if they appear stable. All rocks and soil on a slope slowly travel downhill. The ground beneath this tree in this picture, shown to the left, or actually to my right, is moving so slowly that the tree trunk curved as the tree grew. So the rocks and soil are slowly shifting downhill, carrying the roots and things with it a little bit, which is creating this curve that you see in the tree. This curve right here in the tree was created by mass movement. So this is a very slow process, an extremely slow process. The movement of material downslope very slowly is called creep. Factors that contribute to creep is that water can loosen the soil and allow the soil to move more freely down the slope. Plant roots can act as wedges that force rocks and soil particles apart. And burrowing animals underground can loosen the soil and rock particles, which can help the mass movement process through creep. All of these factors can make it easier for the soil and ground particles to be pulled downwards towards the hill. So here's a question. As the soil on this hill shifts, how is the tree changing so that it continues to grow upright? So if we take a closer look at this picture here, on this side is uphill, on this side down here is downhill. So how is the tree compensating for the fact that the soil or the land is slowly shifting down slope? So here's another example of that happening just in video form.
A hillside, and I've come across a tree that is exemplary as it illustrates a phenomenon called creep. Creep is a geological phenomenon that occurs when the sediment and the soil of a hillside slowly move down the hill gradually. So you can see now, I should probably step back just a little bit. Maybe boulder. Oh, be better. Can you see how this large tree has come out of the ground and makes an angle up like that? That's its compensation for creep. This entire hillside is slowly moving down the slope at probably a perceptible rate. And to compensate, the tree has been growing in an angle like that to compensate, to to remain in a vertical posture. It's an old tree and it has some beautiful lines there. Illustrating this phenomenon illustrates a fascinating concept of geology, creep. You can see it all over the world, especially in humid places where there's lots of rainfall. Take care, everybody.
Your description for creep is here. An extremely slow movement of material down slope. So here is your description for creep. Do your best to draw an image of maybe those angled trees. And then this is an example of erosion. This is an example of erosion. So that was an example of slow mass movement. Our next few examples are examples of rapid or fast mass movement. Rapid mass movement can happen suddenly or rapidly. It can be very dangerous and destroy everything in its path when it happens. It tends to happen on steep slopes because material is more likely to fall down a steep slope than a gentle or shallow slope. So the three examples we're going to look at are rock falls, landslides, and mud flows. Rockfall happens when loose rocks fall down steep slopes. Steep slopes are common in mountainous areas. Gravity causes the loosened and exposed rock to fall down those steep slopes. Rocks in a rockfall can range from size of small pebbled fragments to very large boulders. Landslides. So rockfall would be an example of erosion. Landslides. Landslides is a sudden and rapid movement of a large amount of material down slope. Landslides carry away plants and animals and vehicles and buildings. Heavy rains and deforestation, construction on unstable slopes, and earthquakes are all things that can increase the chance of landslides. So here's a short video clip to discuss landslides in a more detailed manner.
Landslides occur when gravity overcomes the frictional forces keeping layers of rock in place on a slope. The ground we stand on is made up of layers of different rock and other materials. Often, a weak geological layer, for example a fragile layer of shale, will form a failure plane, which makes a slope unstable. The mass of material on top of this plane can be held in place by friction alone. If something happens to disrupt the balance, then the top layer of land can slide away. Heavy rain is a common cause of landslides. The water adds weight to the upper layer, and resulting mud acts as a lubricant. This extra weight and reduced friction can cause the upper layer to slide away. Deforestation can contribute to landslides too. A network of tree roots will hold land in place, but if the trees are removed, the roots rot and the land becomes liable to slip. Earthquakes can also trigger landslides. As the ground shakes, the upper layers of rock can become dislodged. It is possible to support unstable ground by drilling long metal bolts deep into the bedrock to hold the upper layer in place. Some landslides happen extremely slowly, making buildings unstable as the ground beneath them creeps over many years. Another form of rockfall is caused by coastal erosion. As ocean waves collide with cliff rock, they can wear it away over time. When the weight of the resulting overhang overcomes the strength of the rock, it will collapse.
So in this image you have two slopes, slope A and slope B. Based upon what you know about landslides, which slope would a landslide more likely occur on? Slope A or slope B? And why? The answer is slope B, because it is a more steep slope, and the steeper the slopes, the more prone it is to a landslide or a rock fall. Another example could be is the fact there's slightly less vegetation on this slope also. Mud flows. Landslides are also an example of erosion, but after the land stops sliding, where all of that material is then left behind would be an example of deposition. Mud flows. Mud flows are a rapid movement of a large mass of mud and debris. Mud flows happen when a large amount of water mixes with the soil and rock. The water causes the slippery mud to flow rapidly down slope. Mud flows happen in mountainous regions after deforestation has occurred or when a long dry season is followed by heavy rains. It can also happen after a forest has experienced a forest fire, or it can happen after volcanoes have erupted in an area. Deforestation is when an area has had a lot of trees removed in the area. We basically removed the forest. So here is an example of a mud flow. This mud flow happened in Australia. The picture quality isn't perfect, but it does get better as the video moves forward. The sheer power of this mud flow flowing down slope is moving very large debris with it. The mud flow is kind of happening in the channels of a river, but it goes beyond the river's channels in many places. So then the cleanup efforts start. This is not easy to clean up. The sheer mud and size of the mud and heft of the mud is great. If you ever had to clean up any of the debris after our own flooding, you know how unfun that is, and it would take them weeks to really clear up all of this mud. And as it dries, it's just going to turn into almost cement. Volcanic eruptions or heavy rains on volcanic ash can produce some of the most dangerous mud flows that we have seen. Mud flows of volcanic origin have a special name. They're called lahars. Lahars can travel at very great speeds, at greater than 80 kilometers per hour, and can be as thick as wet cement. So some examples of some lahars we have here is, this is a lahar that happened due to the 1980 eruption of Mount St. Helens.
One were dead or missing.
Japanese car sometime.
Rotor wash from the helicopters kicked up great clouds of ash, making rescue difficult. In many places it was impossible to land. Rescuers were lowered by cable to assist survivors who were then reeled to safety. Tons of ice and snow, melted by the intense heat of the raging volcano, mixed with the ash and began rampaging down the flanks of the volcano. One mud flow reached Swift Reservoir, about 10 miles to the south, but it was the debris-laden walls of water which tore down the North Fork of the Toutle River that proved most spectacular and devastating. After wiping out an entire logging camp, the deluge raged on. In a matter of hours, this river of destruction surged under the Toutle River Bridge on Interstate 5, closing the main arterial between Portland and Seattle. Entire forests and logs, hundreds of years old, roared past stunned onlookers. From the Toutle to the Cowlitz to the Columbia River, first attempts at clearing the debris became exercises in futility. For the first time in decades, the lower Columbia River was closed to freighter traffic. The raging torrent had left its mark.
So this would have been additional destruction on top of the destruction that the
In a matter of hours,
volcano
the
had,
carried the growing
and then the
over
ash.
Idaho and Montana. A month later, the plume had circled the entire Earth. In the wake of the plume, ash was everywhere. In some places, the price of a surgical mask quadrupled. Ash doesn't melt. Water turns it into a thick, grimy substance like wet cement. It's as back-breaking a job as moving a mountain should be.
And then this video clip is looking at lahars and how they look after the fact. So he's going to be looking.
There's plenty of sandstone in this part of Washington, but not here. These are volcanic mud flows, 10 million years old. Lahars from an extinct volcano. And you might be surprised to hear where that volcano used to stand. Notice the big cascade rocks floating in the middle of the deposit. Fragile chunks of white pumice. No sorting of the rocks by size that you'd see in a sandstone or river deposit. This thing formed quickly. No time for the big rocks to settle out. 3 lahars are exposed in this cliff, but there's a total of 15 lahars in a stack of light-colored layers here, totaling 1,000 feet thick. Lahars form when cone-shaped volcanoes erupt. During the eruption, the flank of the volcano fails. Water and glacial ice in the landslide mix with rock to convert the landslide into a volcanic mud flow, like a slurry of wet concrete. Lahars follow river valleys and are deadly to those in their path. The lahars have been clocked at up to 80 miles per hour and can be up to hundreds of feet thick, stretching from valley wall to valley wall. Remember the Duwamish River entering the Puget Sound in one of our first episodes back in Seattle? The Duwamish drains an area between Seattle and Mount Rainier. 5,600 years ago, a Mount Rainier that was 1,500 feet taller than today erupted, and the northeast flank of the mountain failed. The massive Osceola mudflow, a 400-foot thick lahar that surged 50 miles per hour down the White River, poured into the Puget Sound 60 miles from the mountain. Fine sands from the Osceola have been redeposited as far north as where the Duwamish River enters the Sound in downtown Seattle. More than 150,000 people now live on the Osceola lahar, and Mount Rainier, an active volcano, has rebuilt itself and is poised for its next eruption. So are these volcanic mudflows at Thorpe from Mount Rainier? They're not. You go upstream on the Yakima River from here, you don't head towards Mount Rainier. And besides, these volcanic deposits here are heading a different direction. These mudflows extend to the southwest, beneath hayfields, beneath I-90, and continue all the way to the William O. Douglas Wilderness Area west of Yakima. 10 million years ago, a cone-shaped volcano erupted near White Pass, and a river valley once flowed northeast from the White Pass area to here in Thorpe. There's a buried river valley underneath Interstate 90 at milepost 98. Since 10 million years ago, a series of ridges have uplifted south of I-90. The old river is gone. The old volcano is gone. The lahars at Thorpe, striking evidence for just one of many extinct volcanoes in the Cascades.
So not only did this do a great job explaining how volcanoes can affect mass movement and lahars, but also how our Earth is constantly changing. So things that are happening today, similar things happened in the past too, but you have volcanoes that existed millions of years ago that aren't there anymore. You have volcanoes that exist today. Volcanoes can erupt at different times. We have mud flows and rock falls and erosion and deposition of all kinds. The Earth is under a constant changing process, and it's happening very slowly, but it's happening consistently. The constant change of Earth's surface. Thank you.